Hi, my name is Shadmin Shahzahan, and today I'll be presenting our Rust game project for Concept in Programming Languages course. And I have worked with one other teammate. His name is Monzi, and I'll be presenting what the game is about. The game is called Space Explorer, and the goal of this project was to build a non-trivial game in Rust while applying a Chapter 6 data type concept. Um, the topic included um, enums, structs, option types, and result types. The overview of the game is called Space Explorer. Is a turn-based terminal game where the player navigates on 8x8 grid of space sectors. The player starts at coordinate 00 grid and must reach the goal planet at 77 grid while managing fuel and avoiding black holes. Each action has consequences, and the game includes multiple win and loss conditions, making it more complex than simple games like tic-tac-toe. So how to run the program? The game is written in Rust and runs using cargo. After cloning the repository and navigating into the project directory, the game is started by running the command cargo run. Before cargo run, you must see if you have Rust installed. In order to do that, you just simply type cargo dash dash version, which shows you if you have Rust installed. For Windows, just typically go to Rust website to install Rust, and for Mac, you have to still go to the Rust website and figure out the Mac command based on what Mac you have and type it in terminal and you will install Rust. So as you can see, if you do cargo run, that will take us to the board selection feature. Before the game begins, the player is asked to select a board preset. This is implemented using an enum called board type, which includes options like classics, dangerous, and fuel rich. Using an enum here ensures that only valid board layouts can ever be selected, which is a direct application of enumeration types from Chapter 6. So I will walk you through how the game works. So if you press 1 to start the game, this is our game board. Like I said, press 1. The way to move around the map or the space sector or grid sector is WASD. If you press D, you'll move D or right side. Your place is P and your position. The goal is the G is the goal target planet. You have to get there by simply using WSD. Fuel is to recharge fuel. As you can see, you start with 12 fuels, and then as you move around, you will lose amount of fuel. So when we go to F, we recharge the fuel, keep going, and then we'll recharge fuel again, and then we got to our target planet, and then the game ends. The game also ends if you run into one of these black holes or run out of fuel. So the game makes extensive use of Chapter 6 data types. Enums, one of them, like I said, how you can see enums are used here. Enums are used throughout the program to represent the finite states such as player action, board types, menu choices, and game stats. This prevents invalid stat and forces exhaustive handling using match segment or match stat main. Structs. We use structs here underneath to group related data. For example, GameStat struct stores the player position, fuel level, turn count, game status, board layout, and selected board preset. Option type. We use option type in our game.rs, which is right here. You can see structs are the scan feature returns an option type because fuel may or may not exist on the board. This forces the program to safely handle both cases. Another type we used was result type. The player action returns a result type which allows illegal moves such as moving outside the map to be handled gracefully instead of crashing the program. So our result type is within this function. Um, and difficulties and solutions. So the difficulties we had, one major challenges we had was dealing with Rust ownership and borrowing rules, especially when updating the game stat. We solved this by centralizing all state mutation inside control functions using short-lived mutable borrows. Another challenge was handling user input safely, which we addressed by converting all input into enums and rejecting invalid values early. So the good and the bad and the ugly side was what we liked. So the good, what we liked about this project was the Rust type system eliminates entire categories of bugs. The challenge part was Rust like a steep learning curve, especially understanding the ownership and borrowing. At time it felt frustrating, but those constraints ultimately led to a much cleaner and safer design. So this assignment helped us think about the programs in terms of a data modeling instead of just logic flow. Uh, Rust compiler acted more like a teacher than an obstacle, guiding us toward a better design decision. Overall, this project demonstrated a strong application of Chapter 6 data types and is something we would confidently include in our professional portfolio. Thank you for watching.